All right, let's dive in. Today, we're going to take a totally standard Go web service and give it a massive upgrade. We're talking about transforming it into something that's robust, modular, and actually production ready. And our secret weapon for this whole makeover? Well, it's the super powerful UberFX framework. You know the feeling, right? You start a new project, everything's nice and clean. But then, over time, your main.go file just grows. It becomes this tangled mess of dependencies and hard-coded logic. Sure, it works, but it's turning into a real nightmare to manage, let alone test or change anything. Sound familiar? Well, the good news is there is a much, much better way. In this explainer, we're going to map out a clear path to get from that tangled up monolith to a clean, elegant, modular design that you'll actually enjoy working with. So let's get into it. Okay, so first things first, we got to really understand what we're dealing with. Let's take a hard look at the before picture. The classic tangled monolith. So in the beginning, this application pretty much lived inside one single file, main.go. I mean, the server's startup logic was all hard-coded, which made it super rigid. Testing? Forget about it. It was nearly impossible because everything was so tightly coupled together. And maybe the biggest sin of all, it had no graceful shutdown. And as you know, that is a huge no-no in any production environment. So how do we fix this mess? This is where we bring in the hero of our refactoring story, UberFX. And trust me, this is where the magic really starts to happen. For anyone who hasn't used it, what is UberFX? Well, think of it as a dependency injection framework made specifically for Go. Its main job is to be the general contractor for your application. It manages the whole lifecycle of your components, it handles all the configuration, and it forces you, in a good way, to build a clean, modular app. It basically takes all that tedious manual wiring work right off your plate. All right, so how does this thing actually work? Well, it all starts with a really simple but incredibly powerful idea. You just provide your components. The whole system is built around fx.Provide. The best way to think about it is you're handing FX a recipe book, or maybe a parts list, for your entire application. You're just telling it, hey, here's how you build my database connection, here's how you construct the HTTP server, and here's where you get the configuration. You give it the constructors, and FX figures out the rest. It's awesome. Okay, so FX now knows how to build all the individual pieces. What's next? Well, now we have to tell it what to actually do with them. And that's where Invoke and the application lifecycle come into the picture. Let's make this super clear, because it's the most important distinction. If Provide tells FX how to build the parts, Invoke tells FX what to do with them. So, for example, you'd provide a function that creates your web server, but you'd use Invoke to actually start that server and register all your API routes. See the difference? One builds, the other acts. Now this is probably one of the biggest wins you get with FX. It gives you these incredible lifecycle hooks. With OnStart, you get to define exactly what needs to happen the moment your application boots up. And even more importantly, with OnStop, you can guarantee that everything shuts down cleanly. You can close database connections, let active requests finish, all within a timeout you set. For reliability, this is absolutely crucial. Okay, so we've done all this refactoring, we've broken things apart, we've wired it all up with FX. What's the real payoff here? Well, the proof is in the testing. That's the answer. With this new structure, you can now run true behavioral tests with a single command. I'm talking about spinning up your entire application, hitting a real endpoint with a real HTTP request, and checking the response. No more clunky mocks or isolated unit tests that might miss the bigger picture, just one command. So what does a test like this actually look like? It's honestly beautiful. Your test function just starts up the full FX application. Then it sends a real HTTP request, say to your /health endpoint. It checks for 200 OK status code. Then it can actually parse the JSON in the response body to make sure the message is correct. And when it's all done, it cleanly shuts the entire application down. The confidence this gives you is just incredible. You know your system works end to end. So after going through this whole refactoring journey, what are the big lessons? Let's distill this all down to the key takeaways. So let's recap. First, UberFX is an absolute game changer for managing your application's lifecycle, seriously. Second, forcing yourself into a modular design massively improves clarity and, as we just saw, makes your app way more testable. Third, behavioral tests are just invaluable. They prove your application actually works as a cohesive unit. And finally, pulling things like port numbers out into a configuration struct makes your app so much more flexible and ready for any environment. And that's a wrap. The real point of all this, of course, is to see how you can apply these same ideas to your own code. So I'll just leave you with this one question to think about. As you look at your own projects right now, what's the first tangled piece of code you can think of that could use a little bit of this modular elegance?